Welcome everyone to this session, and thanks DJ for intro. We have a pretty packed agenda for the next 30 minutes. We'll start with some of the business challenges that we see with our existing customers and the opportunities it presents for optimization. And then we'll move over what is Ultra and how it helps solve some of those challenges. Um, We'll then move into double clicking Ultra and kind of comparing it with the standard mode of execution that's available on our platform. We'll also understand the detailed deployment architecture. We'll discuss some real time use cases and followed by some tips and best practices. We'll also discuss some real world success stories that we had with our existing customers, and we'll open up for Q&A. But in the meantime, if you have any questions, feel free to put it on the chat, and we'll try to answer, as much as we can during the session. With that, I'll move over to the next slide. So we'd just like to start with a poll question. And the question is, what integration challenge is the most critical for your business? Um, there are 5 options there. If you'd like to participate in the poll, it's optional. We'd like to hear, your answers.
The mission critical integrations that need fail-safe execution, that is the second option. I think that got most votes, around 66% of the votes. So yeah, that seems like the integration challenge that is on everyone's mind.
Great. Yeah. So with that, we'll delve into some of these business challenges that we see. Like we do understand that modern integration is built on cloud platforms and they're time insensitive. There are changes that happen rapidly. The data workloads are unpredictable these days, right? There's a need to scale out, vertically and horizontally. There are situations where we are exchanging data with multiple stakeholders, where we have more real-time requirement. The APIs need to respond within an SLA. There's a low latency and a high concurrency type, situation in almost all the industries and almost all the verticals. And these challenges present certain opportunities where we can go and augment this, and augment the architecture by introducing this feature Ultra, where we can provide help to more mission critical type application, make them more fault tolerant and resilient on our platform. So this discussion is going to be mostly around how do we do that and what features in this platform helps you do that, right? Uh, so essentially, from the platform perspective, Ultra is a kind of a data pipeline technology that enables businesses become more reliable on this platform, right? Complete workloads in a more real-time fashion, and since these workloads are time sensitive, we do try to adhere most of the time to the SLAs, which can sometimes be sub-seconds, right? And this applies to all the tasks and business processes that you would run on this platform. Um, so if you compare this with the standard mode, um, it's obvious by now that Ultra is more like a execution mode, wherein a job or a business process is always running, looking for requests that needs to be processed, versus the standard mode, which is more like a trigger, right? If you look at the basic differences, a trigger task running on this platform is comparatively higher latency. It sometimes takes few seconds for the task to complete, if not minutes. Whereas in Ultra, it's more around having all the business steps within the business process completed within sub-second or very low latency, at the same time supporting hundreds of concurrent requests. So it's not just low latency, it's also on the high concurrency side, right? We do have all the goodies that we have on the trigger task on the authentication and authorization. We do support quite a few flavors, how these tasks could be secured. And then, whereas on the trigger task or in the standard mode world, there is a configurable limit where we can configure on this platform, like how many API calls takes place within a stipulated time interval. Here, you are limitless. Basically, there are no such limits, right? You're not counted against a limit that how much or how many tasks you're executing, how many APIs are getting invoked. Because our understanding is these will be more low latency and highly concurrent requests, and there could be thousands of those requests, that can take place within a 24 hours period. From a deployment architecture standpoint, right, Ultra comprises of two main components. The first component is often referred as feed master, and the second component is the same, pipeline execution engine that our platform offers to process your data. Now, um, the feed master acts like an interface between the client application and the execution, engine. It also has an inbuilt brokering mechanism. It has an incoming and an outgoing queue where we can queue these messages, especially when there's a need to have a guaranteed message delivery. Plus, you can imagine that Ultra is more like a moderator, right, between your client applications that issue these requests and the execution engine that process those requests. So it not only guarantees the delivery of these messages, it also correlates these messages between the node, execution node, and the client application. So it does use the message ID for correlation. And then it also has all the metadata that it needs to process these requests, reducing any dependency on a control plane, right? So that is the architecture of Ultra. Moving over to the deployment option, it can be as simple as one single feed master talking to more than one execution node, thereby guaranteeing message delivery and at least processing the data request once, right? At the same time, providing the goodies like low latency, high concurrency, and zero dependency on the control plane, right? When I say control plane, I mean the SnapLogic platform, which is on AWS, right? Um, what we recommend in real-time scenarios is in production, especially in production environment, we recommend having at least two feed master because it gives you just extra layer of resiliency with more HA, right? The request can be load balanced within these two feed masters, and it's more highly available, right? Um, we also have deployment option, which can be multi-region, especially when you are, let's say, you're deploying these execution on a cloud platform. So, for instance, yesterday we just had an outage, like AWS had an outage, not we. AWS had an outage in their US East region. So, if there were, let's say, execution in nodes deployed in US East region, were out for almost 4 hours, right? So, we do provide a multi-region deployment option where these feed masters can be deployed across regions. So, even though there is a cloud vendor which has an outage, these mission critical applications can still run in a fault tolerant way. And even if those outages were somehow going to impact SnapLogic at some time, still these execution will happen because these nodes will have all the information, all the metadata that it needs. So there will be zero dependency on the control plane. And just because we'll have a multi-region deployment, if one of the regions was out, the feed master and the execution node from the other region will be able to still process it. Now, the last option that we often talk about is in headless Ultra, and this works when, let's say, one of our customers have already invested in some sort of brokering technology like Kafka, like RabbitMQ, and whatnot. In that case, what we normally recommend is doing a headless Ultra, where our execution node can directly converse with their Kafka or their RabbitMQ instance, and then basically Kafka becomes the feed master, right? And we do exactly the same thing that you saw in the architecture. We'll bring in the same fault tolerance, resiliency, and the streaming capability with some of your, with Kafka consumer or Rabbit consumers. So you'll be able to stream data over a REST API. Going back to a fault tolerant architecture, like I was saying, it'll be good to have two feed master node deployed in more than one region for HA and DR. And then these feed master nodes can load balance request to execution node in a round robin fashion, right? And the clients can still interact with these feed master through a load balancer so that, the high concurrency scenario can be supported. Like you can have hundreds of requests, coming within a minute, and all these requests can be easily distributed over these feed master node and process faster. We'll delve into some use cases where we can deploy this. We can use this feature. So with that, I'll move into our SnapLogic Designer platform, and we are going to talk about a real, a very common use case, where customers go to an e-commerce portal and they build their cart, they add, items to their cart, they process a payment, and then they basically submit the order, right? So once the order is submitted, an order ID gets generated, which is then used as an ID to track the status and also to fulfill that order. So it's a typical order, submission and fulfillment use case. So as you can see that we have our SnapLogic IIP. This is the designer platform where you can design pipelines. So as you can see, there are pipelines like create order. So this is like when a customer submits an order, right, or submits a request, this pipeline gets triggered, and basically it enriches the data, whatever data it has received from the endpoint, and it further enriches the data by interacting with other stakeholders, and then it basically generates an order ID in a very quick fashion, and also it queues up the request to basically a queue system, right, where it can be processed. Now, while it generates the order ID, it does do some data validation. So we do some check the data that is coming from the API, whether it has all the items or not, whether the SKUs are matching, right? Whether we have the item available in the inventory. So it does all that validation before accepting that order and generating an order ID. Similarly, we have a pipeline that basically takes those valid orders from the queue system and it sends it to downstream applications for further fulfillment, right? And as customers submit these orders, they would definitely want to check the status of their orders. So we have a pipeline that basically checks the status of the order and also does some validation whether the order ID that this customer is sending me is correct or not. If it is correct or if it is blank, then we can handle errors. And if the order ID is the correct ID, we can go and look up and we can get the current status of where the order is in terms of fulfillment, and we can provide these statuses in real time. Now, once these templates are built on this platform, what we do is we basically create tasks, and that is where Ultra comes in, right? So as you can see, using the templates that we saw, we can create these tasks, and that's where, as a designer, we define where do we want to execute these tasks. So we have an Ultra deployed on a Snaplex, and then we select the run policy as Ultra, which means that these tasks are going to be executed in a more low latency, high concurrency way, right? We do define number of Snaplexes, so it's good to have at least 2 Snaplexes processing these requests so that these high concurrency, low latency types requests can be load balanced through at least 2 instances, right? And then this API, these tasks can be secured using bearer token, and we can define the concurrency limit, like how much concurrency we want to allow, because definitely by exposing these tasks, we don't want to be exposed to an outside internet where people can just write some code and do a denial of service attack, sending us hundreds and thousands of requests in a second and just bringing our servers down. So you can definitely define those max limits, right, on how much concurrency you want to support and how much throttling that needs to happen. And then you can also put a number for your fault tolerance, like how much failures you're going to count. Once that has been done, the Ultra task is deployed and it is available as an API for upstream applications to consume. So with that, I'll move back to the slide. So this was the real world example. As I said, these are the 3 APIs. So what I'm going to do is I'm going to take, I'm going to assume that we have a shopping cart like Amazon or something, and people are rapidly submitting requests. So I have a test data with hundreds and thousands of such requests, right? So I'm going to run that pipeline, right? And as you can see, as I'm running the pipeline, these requests are getting submitted. So if we go back to the dashboard, you would notice that these requests are getting submitted to the infrastructure and the counts have started changing, right? So these are, as you can see, the Ultra pipelines that are running. The one that's currently being used is the create order, right? Where the order is getting submitted and it's getting created. As you can see, these numbers are refreshing now as that request is getting processed from my runner in Postman. And then at the same time, these requests are being taken up by the process order queue to fulfill. So both the counts, as you can see, will keep will change as these requests are processed. Now we can go to an individual task and we can look at the latency. So as you can see, let me refresh this. The create order API task is running, and this is the overall request it is receiving per minutes. Some of the requests are getting error out because of the data is not valid or there's something missing in the data, right? And then this is the latency, overall average latency across these 107 requests, which is around 655 milliseconds, which is still less than a second, right? Um, so as you can see, these tasks are really working in a very low latency and a high concurrency manner. Now you can still go and check the status of an order, right? As these requests are still getting processed, I can go and check a specific order, and I can check as a customer where my order is, right? So that's also sends a request to one of the Ultra tasks, and it would show up here. Like if I refresh the screen, the get order status API was invoked, and we got a response in 310 milliseconds. Like, what is the status of that order? So this was kind of a demo of the Ultra feature. We'll move on from here to the tips and best practices. So what we have seen is these concurrency and low latency type scenarios can change over time. There could be times like month end or quarter end or holiday season where these requirements can further go up, like how much concurrency and low latency you want to support. So a general best practice is to separate the workloads, like identify what kind of workloads you have and separate up them on different execution. For instance, if you have more low latency, high concurrency type workloads, which are more compute intensive, it's good to deploy it on a separate infrastructure than the normal daily routine workloads, which are more memory intensive, which are more batch type workloads. So one of the best practices to separate the execution. Then basically you are creating an environment for the execution engine to support more concurrency, more low latency as these peak seasons approach, right? Like when you are in a month end or a holiday season. Um, there are certain things that we do in a typical batch job, like processing data, applying aggregates and joins and whatnot. We recommend not doing those joins and aggregation and normalization within an Ultra pipeline, because that's more applicable to batch type scenarios where you're doing a lot of transformation data. Here, this is more like a business process scenario where you're doing validations on that data and then processing it quickly with the stakeholders with the backend applications. Now, we do have a very aggressive roadmap where we'll put more guardrails and checks and balances on what can be deployed as an Ultra task versus what cannot. That way, users may not have to figure out that nuance of what would be the best practice of implementing an Ultra pipeline. But our platform will start making recommendation that, hey, looks like these are the steps that you would like to use to build your Ultra pipeline. Similarly, there are certain set of snaps which are more optimal for doing bulk loads and huge volumes of data. We don't recommend using those snaps in an Ultra pipeline, but rather focus on the low latency, high concurrency, and processing data faster than processing huge volumes of data. With that, we move on to the customer success story section. So we have our existing customer, like a large content delivery network provider, who uses Ultra pipeline in their production environment, like I said, to handle sudden spikes during month end, quarter end, and the holiday seasons. Similarly, we have a US-based gaming retailer who uses this a lot, during the holiday season and the Black Friday season to scale up vertically, and they really have a low latency type scenario where their APIs and pipes has to scale up, right? We have a very large generic pharma company who uses Ultra not because they have a low latency and high concurrency type scenario, but they have more workloads like that. It's okay to complete the workload in more than 1 second, but then these are mission critical for them. That means they want the fault tolerance and the resiliency feature for Ultra. So basically, these are three examples where different customer are running mission critical application, and the definition of mission critical is different for each one of them. Some of these customers have for them mission critical means low latency, high concurrency. For others, mission critical means fault tolerance and resiliency, that even though there was a network outage, there was a cloud outage, still they should be able to run their mission critical workloads. With that, I'll hand it over to Dhananjay.
Thank you, Gyanesh. Awesome demo. It's great to see the responses getting back in 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 hundreds of milliseconds, and I know that number can even go to like tens of milliseconds. So before we go to questions, I want to quickly cover Summit resources. So if you are not a SnapLogic customer, you can try out SnapLogic by signing up for free trial. If you are a SnapLogic customer, you can get complimentary training and get certified. And with that, you'll get this cool badge that you can put on your LinkedIn. And also, don't forget to join the conversation with your peers in SnapLogic community, and you can ask questions, and you'll get answer from not just SnapLogic team, but also a lot of the peers who are very active on the platform. And then finally, you can also download assets like how to best implement SnapLogic, and all of those are available in the resources section on our website. So with that, yeah, we'll go to Q&A, and Ganesh, we have a question here. So let me ask that. So how do you organize version control of the data pipeline? And I think here
That's a very good
it
question.
and
Yeah.
then how do you organize working together on the same pipeline?
Mm-hmm. So that's a good question. That's a typical version control scenario. So yeah, some of our customer have a version control system that they use, like GitHub or Bitbucket or Azure, DevOps. There are others who use the platform as is. They don't have a separate version control system. But then to your point, we are tightly integrated with these version control system where you can define a data pipeline and you can practice SDLC, where these pipelines can go over multiple versions as you move the data, pipelines from development to QA and QA to UAT and UAT to production. And we integrate with these version control systems. So essentially, since we are not expecting you to write any code on our platform, but rather drag and drop and configure a pipeline, you do not have to too much worry about the content of the file itself, because the pipeline is stored as a JSON. So we would never expect you to go and edit the JSON in a JSON editor and do a find and replace and do a commit. But think of it like you can go and make changes to the pipeline, and you're, as a developer, you can check in and check out these pipelines to a version control system of your choice.
Yeah, and also an interesting point comes to my mind. So when you have a pipeline that is always running, how do you do version control on that?
Sure. So when a pipeline is already running, let's say an Ultra pipeline, right?
Right,
It's deployed and running. Any changes that happened after that can be deployed as a new version of an Ultra pipeline, right? And that's like the basic service oriented architecture principle. You do not want to interrupt the running pipeline because it could be taking request on the fly, right? There could
right.
be in-flight requests. So you will go ahead and deploy this new version of the pipeline, and slowly you will deprecate the other pipeline. And that brings a great point where we also have a full lifecycle API management solution on our side, where you can have publish these pipelines, and you can say that how you want to manage the lifecycle of these pipelines, right? Like
Right,
deprecating them and all that. Mhm.
right. Yeah, great. Uh, Another question you have is, okay, how do you, yeah, I think we shall add that same question. How do you perform maintenance upgrades on the platform when you have Ultra pipelines?
That's a great question. So one of the things that differentiates Ultra from a triggered pipeline is the Ultra pipeline is not dependent on the control plane, right? So let's say the platform is going through a planned outage or even an unplanned outage, right? The Ultra pipeline does not meet the control plane for its execution. It's not even aware of that the platform is going through an upgrade. And by the way, most of our upgrades that we do are zero downtime upgrades anyway, regardless of the model you picked, where like we have two models of one is called Cloudplex, the other is called Groundplex. So when you choose a Cloudplex model, we as a vendor manage the execution of the upgrade of that platform, and you just use that platform as a service, and there's zero downtime. Versus the Groundplex model is where customers take the bits from us, they deploy that bit in their own virtual private cloud or in their own data center, and then we do 4 upgrades in a year, and we give you the option, like you can either authorize us, like you can authorize us by a checkbox saying that, hey, SnapLogic, you can go and upgrade my environment anytime you do this upgrade. Or you may not authorize us, you can uncheck that box and you can still do this on your own. It just takes to restart the system, restart the execution engine to do those upgrades. So it's seamless. and then you have up to 5 weeks to do that maintenance window. So you can find a right window when it will be good to restart that engine. But yeah, since the execution will be restarted, there'll be a minimal downtime introduced, because the engine will get restarted and it will come up again.
Got it.
Yep.
All right. So there's another question. There are a couple of questions coming in. One is around training and certification that we'll not answer right now. But is there a way to deploy pipelines and relevant components in bulk from lower to higher environment? And maybe I can take that. So this is not necessarily related to Ultra, but yeah, we have a process in place, and there will be more updates coming up in the future on moving artifacts from one org to another, like your dev environment to your production environment. So there will be you have those capabilities now today uh, with uh, with some of the capabilities of the platform, but more of that ease of use is coming up in the near future. I do have one question around message queues. So when I think of different like a Kafka or different message queues like PubSub, like is Ultra kind of the preferred way? How do you think of it, Gyanesh?
Sure. I would say yes, because Ultra is not just a broker, but it also is a gateway, right? It acts as a gateway. It acts as a broker. It helps you stream data over through the platform. Plus, it gives you that inbuilt fault tolerance and resiliency. And what I mean by that, and what it means for you, is it does not need any dependency on the control plane, because it can store all the metadata with itself and can work seamlessly, right?
Right. Okay.
Whereas a
Awesome.
typical Kafka or a RabbitMQ would be more like acting as a pub sub, where you can go and publish and subscribe and make sure that you have a guaranteed delivery of message. Yep.
Got it. Okay. Awesome. So we are almost at the end of our time. So thank you very much, Ganesh, for the demo and insights into how to use Ultra, not just for low latency use cases, but more and more for critical mission critical applications. So thank you very much.
Thanks, everyone.
Thank you.